This is the Person of Interest podcast, where we meet extraordinary people with a story to tell.
Welcome back to the Stockholm School of Economics in Riga for another of our podcasts. Today I'm joined by someone for whom these surroundings are quite familiar, far more familiar than they are for myself, in fact. His name is Rihards Garančs, and he's a lecturer here at SSE Riga. But looking at his resume, lecturer was about the only word that I understood. There are various other abbreviations and terms linked to your name, Rihards. I'm going to get you to explain them in just a second. Right. So there was BSc elective course, Excel advanced, EMBA course, and big data. Now, I've got a vague idea about big data, which I think we'll be concentrating on a little bit later on. But maybe you could fill in a little bit of the background about who you are and what exactly you do here at SSE Riga.
Yes, thanks. So personally, I have now a bunch of courses, but everything revolves around data. So we start off in bachelor with year ones, and it's Excel that has morphed into data analytics, which is more about how you work on day-to-day jobs with Excel, and then some tips and tricks on how you analyze the data, how you have a big data pile, and how you can actually make sense out of that. So we start with that, then we continue on a bit more advanced, which is the Excel advanced part, which was morphed into data automation and business intelligence, which kind of takes it up a notch, where we look at newest systems which help you to automate different errands or different data reporting on that. And as a matter of fact, I have a company that solely focuses on that. And lastly, year three we have a lecture which is artificial intelligence. And interestingly enough, this is today was the last lecture.
Okay.
Of that course.
You've been replaced by a computer.
No. No. I'm actually teaching that that there might be being replacements by computer, and there we look at three aspects. One is this data, how to set up the data for artificial intelligence, and it's more about data science, where you actually use different data algorithms like machine learning or kind of a different deep learning networks to that they are understanding them a bit more. And we actually have a class where we kind of they will learn how to do an image recognition, for example, algorithm on their own. Then the second is digitization, which is more about understanding how world is being digitized and what are the impacts of digitization, what are the characteristics of digitization, and then how companies are using that. So one of the biggest kind of buzzwords around companies is digital transformation. So I kind of try to decipher that for them. And lastly, it's about AI in general, which is more on what big tech companies like Google, Facebook, or Microsoft are doing in terms of different AI agents, and then what are their things, and then what are the implications in the future of that. One of them being that some of the jobs might be replaced by an AI agent. And then I have also here in the MBA courses on big data analytics, which is kind of bits and pieces of all of these elements, but more targeted towards already experienced professionals and how they can actually implement that in their own companies, and what are the takeaways from that.
And from what you're saying, is this something that all students here at SSE Riga are going to encounter, or is it more a specialist strand?
No, actually, it started off as an elective, but actually, as we move forward in school, we realized that this is something as a crucial skill that is needed for modern working environment. So actually, from this year, they even are learning programming language, and it's kind of being put in different courses. So that helps SSE Riga to be but advanced, and we're producing students that are understanding that how actually those tools can be used in the companies. And also these courses, I think, for example, this artificial intelligence course was just launched this year. We start off with that, and I think that helps to become acquainted, understanding that there's really in the business there's a trend that's you cannot ignore it. It's not even a trend; it's something that's happening on a day-to-day basis. So we kind of want the students to take advantage of that and be aware of it.
And if we can just rewind slightly, I mean, how did you develop your interest in data and in statistics and so on? Because I think it's one of those things where a lot of people run at great speed away from it. Other people are really sort of magnetically attracted to this. I mean, what was it that attracted you?
I think for me, the funny story is that when I studied here, I thought that I will not be this guy who will sit in Excel because I hated that. And I said I will never work at Excel. I'm going to do some strategy or other things. But as kind of my destiny turned out to me, that one of my first jobs was where I had to intensively use Excel. And then I realized what is the power of it. So what actually you can do with it. Once I realized the power of it, I had kind of good teachers who were my managers before that. And I realized what are the possibilities for that. And that's when I started to develop it. And then for me, there were 2 long years to learn it and then understand it and develop my skills. And then when I looked at it retrospectively, I thought that if I've knew this Excel that I know now, it would be so much better in my life, my career, and then my endless nights that I was spending and kind of understanding it. And then I realized that I wanted to give that to the students, SSE Riga students, this course. So that's how it kind of developed. And then it slowly morphed into more and more, because at some point when you reach the limits of Excel, you thought, okay, what is more in there? And then you looked at big data analytics, the business intelligence, and then to AI. So it kind of slowly evolved into this kind of the thing that it's now.
You mentioned the great power of it, or the potential power of it. Could you just give us a few examples from what you're saying? I mean, I guess people would realize that if you have a certain mastery of Excel or something, it could save you time.
Yes.
But what you're implying seems to go way beyond that.
Well, yeah, it's true, because one of the things that I teach is, let's say you have a lot of data, and then you need to have a kind of understanding of that. Let's say you have different purchasing agreements, different purchasing orders, plus the history of that. And you would like to take a decision based on that. And then you can make a decision just by looking at a couple of numbers that you have, but you can also look at much more broader. So you look at the history, you look at different ways of different angles of how you want to look at that data. And with Excel, you're able to kind of produce a system which allows you to access any data point or any combination of data points with one single formula. I mean, it's actually super easy to do that. You just need to know how to do it. And the best part is everyone thinks that Excel is very much linked with formulas, with coding. Actually, modern Excel has to do everything with buttons, and the code is written for you. And I think that's something that people don't realize. And then when I usually teach this course, then it kind of opens up many people's eyes on that.
Because, I mean, maybe it's the fact that I'm a bit older and I remember kind of Excel when it was coming in. I just think of lines and boxes and spreadsheets, basically. Yeah. But there must have been some sort of huge evolution if you're talking about presenting data, because that's not really presenting data except in a very sort of basic fashion. So what is it that you do with this which turns it into something people can digest?
Well, the first one is what I teach is we normalize the data. So you have to prepare the data, and then these are like 5 simple rules that you have to do. You have to comply to, and then your data is there.
Well, can I just ask you to outline what these 5 rules are, because that might be really useful.
All right, sure. So the first rule is you have to try to split the data as much as possible. Let's say you have a year and a month and a day, and it's in one column. But if I would ask you to analyze me 1 year, then you have to click 12 times, or all of the years. Yeah. So if you split that data, that gives you more information. Yeah. Then let's say you have a product name, which consists of brand name, what is the product type, what is the product container, and so forth. So you can look at it as this one element, but if you split it away, then it allows you to slice the data in 3 different views, which in turn allows you to understand the data a bit more, which in turn allows you to kind of understand what you need to do with that information. So that's the first rule. The second rule is I try to remove any redundant columns. And I've seen when I've been working with companies, or with different examples that I've seen, many people have, many databases have a lot of redundant elements that are completely unnecessary. And many of them, they're not helping you, they're actually distorting your view. Because my personal philosophy is that if you provide a database that comes with an instruction how to use that means you've done a bad job. Yeah? It has to be completely intuitive, and it has to be in a way that any person could understand that. And therefore, so removing these redundant columns can help you kind of ease the whole model itself, and then kind of doesn't clutter your kind of surroundings. The third thing is remove duplication, and in many cases you would have like a subset of elements, then you have a sum of those subsets, yeah, and that adds you extra layer of data, and then you just have to remove that data because you can reach the same result by summing up those elements easily, yeah. And the problem is, once again, if you do not know that, and the person just tries to look at one of these elements, it gives you twice as big amount, for example. And I've seen when I was working in a company that there's been so many times that you would have twice as big result, or you think that you're doing good in the profit margins, but they sum up, and you realize that actually you were wrong. Next thing is I only add columns that you can sum up, that makes sense when you sum them up. Let's say if you would look at the price, which if you sum it up, it gives you gibberish out. So you would remove that column, or you create it as a formula, so that calculates it on the spot. That if you don't have that, then you just add these data points how you to calculate it on the spot, so that it's going to be always correct, but it's not inside the database. And then the last rule is I keep that's kind of a bit more for advanced users, but I keep only one value column, one date column, and as many text columns as you want. And that comes to a bit of how you visualize the data. It goes kind of very, very technical, I would say. I take 4 days to teach that, so I'll not be able to explain that. But the idea, the concept of it is that I create a table which is dynamically filled in. I can slice it in a different way, and I can present any data that I like. So in the sense, instead of you having kind of a million of tables, you can have one table, one chart that you just dynamically fill in the blanks where you want to see, and it automatically calculates you that. So that's the whole idea behind it.
Is there any problem with kind of preempting what you're going to get out of it, as it were, like formatting something in expectation of a certain result, and then maybe ignoring or hiding data that you weren't expecting in there?
I think that's a big problem, and I was even there was one specific job when I was working to actually hide the truth. That was my job, to actually obscure the truth. In a sense, when we were presenting to customers, we had to show that we're the best, and when we were clearly not. So I had to find a way how to show that. So then once again, there are a lot of visual tricks that you can use. Then because actually, you don't tamper the data. You don't kind of I would not change any of the data, but the way you show it, you can show it in such a way that it makes you perceived much better than you actually are.
Well, that's kind of what I was getting at, and is it the case that the students here, and I guess society in a wider context, needs to develop a sort of data literacy, which we maybe don't have? Exactly.
That's one of the things that I teach. I teach all those trickeries, how people can be tricked with the data, and I give them ground rules how to look at that. So first of all, when I look at any kind of a article, I immediately can spot when somebody is trying to deceive me, even or what is the kind of a mission that they wanted to convey with that, but it's just the data does not support it.
Could you just give an example of that, perhaps? I mean, maybe not a specific example, but maybe a technique or something.
I can give you one very famous example. There's this article, I can't remember, I think it's Wall Street Journal, where there was this Iraq's bloody war. And the idea was that they showed that since when the U.S. came in, suddenly the number of deaths were kind of increasing quite a lot. And when they left, then it kind of declined. So what he did, he transposed the colors and he transposed the bars. So actually, the deaths were declining, and then actually it rose enough when they left. And then it was the negative axis basically.
I remember seeing this. Yes, they flipped the axis.
Yes, he flipped the axis. And then it's also the way it was written, it's Iraq's bloody war, although it was should have said that kind of a complete normal narrative, yeah. And then it was kind of red colored, and then there were a lot of elements that were pushing towards a certain narrative, where most of people would be fooled by that. But if you look at these tricks, that you look at the axis, you look whether it's based on 0, yeah. Then you look what are the elements, and it's very clearly to see. Or sometimes you have some inferred elements. I remember in the French article there was written that Air France receives much higher salary, even though they fly much less hours, the pilots. And once again, they showed these, that looks like it's 3 times more, but actually it's just, I think, 20,000. In the grand scheme of things, it was plus 5% that they received more, and then minus 3 or 5% in terms of the hours that they were flying. But they don't understand that was the net salary. And if you compare that to Germany, that they have much higher taxes, actually they would have less salary. So if you look at it in normal terms, it was exactly...
So there was a column missing, effectively.
Yes, exactly. And it was they were misleading information, so they did not give out information that could have told you the truth, yeah.
Well, this was something I wanted to pursue a little more as well, in fact, because it seems to me that if we take, let's say, an old-fashioned bar graph, you need a certain amount of numeracy. You need to understand that there's an x-axis or y-axis, that these are certain units, and you've got the relation between these. So you need several levels of understanding. Whereas something like, I guess the most obvious example of the very simple presentation of data would be these sort of word clouds that you get sometimes on the internet and so on, where all you really need to understand, or at least all that you get in your brain, is bigger, smaller. That's really big. That must be impressive. This is small. Isn't there a danger that in presenting all this data in such simplified ways, we kind of lose clarity, as it were, by neglecting the basic educational aspect which is required?
Yeah, I agree exactly. I think, to be honest with you, one of the things that I've done and I've seen that there are more and more different chart types that you can actually have in terms of way you want to visualize the data. And the thing is that it limits a lot of information. First of all, even though the word cloud seems very easy to understand, but it kind of dilutes a lot of the context. At the same time, bar chart or a table, let's take some simplest form, which is a table. For me, I personally, even though I'm a visual person, I like tables because you can get any information that you like to have, because it's very simple. You know how to read it out. Yeah. With the bar chart, you have to kind of exactly, you need to read these X and all of these elements. And the more complex information you want to convey, the more refined your chart has to look like. Yeah. And I've seen some simple, ingenious ways how you can do that. So I've seen one example. It was there was a kind of chart about typical deaths in US. So when people are dying, and then they kind of had the color coding, which was kind of this red, green, and yellow for different types, whether it was kind of accidents, whether it was heart diseases, whether it was cancer, and other effects. So one of the things was they did very nice grouping. Second, with the color intensity, they showed whether it's increasing or decreasing. And thirdly, they were showing with these bars. In different elements, how it was structured. And I think that's how you should approach it. That when you look at that graph, you don't have to read the axis or labels. You just look at it and it just speaks to you automatically. And I think it takes time to devise those graphs. It takes time and kind of a bit of understanding and experience how to do those. But they should speak. And that's kind of my idea, that if you ever want to do something, it has to speak by itself. You don't have to make an instruction manual to tell what it tells you. So that's already a wrong thing. So.
Well, you've mentioned at the beginning of our conversation both big data and artificial intelligence, which are two of the topics which kind of everyone's talking about at the moment, sometimes in a optimistic way, sometimes in a very pessimistic and sort of apocalyptic way. So I would like to use the opportunity to ask you, how do you see these two things combining in the future? Because surely they're going to sort of multiply each other's possibilities.
Yeah, I think that's the funny thing is that I was speaking exactly to the students today about the whole thing. But just to understand, one element is the exponential growth of these technologies that we cannot, as humans, cannot comprehend. You cannot comprehend exponential change. You think about it linearly. The same thing is today, it's plus 20. And if I would say that tomorrow is minus 30, you could not even kind of visualize that would suddenly some drop. That's the same with this exponential change. We don't understand that. And so you have to be aware of it at least. You have to be aware that such a phenomenon happens, and you have to kind of know when to navigate. So one of the things that I try to teach students is to have this awareness, which is important. That many people speak about AI or machine learning, and then for them it's a buzzword. If I'd ask you, what does it mean? Nobody could give me a correct answer to that. Very few people. And I think one of the things is this kind of literacy and understanding. When you hear those buzzwords, even sometimes people are using them wrongly. Yeah? And I think that's one thing that has to be kind of learned. When you hear these buzzwords, just look at that. What does it mean? or you would hear about blockchain, and then you would hear different fairy tales. What is that? Yeah. So that's one thing. The second thing is, of course, it's like I said, with this exponential growth, it's going to happen and it's going to impact. And the thing is that it's going to impact mostly the graduates that are here. And with the automation, if previously automation was happening mainly with blue-collar workers, then this time with AI, it's actually changing the white-collar workers. For example, accountants or telemarketers or lawyers. These are the professions that, according to McKinsey, I think it was McKinsey, that had 98.5% probability of being automated by 2030. So if you think about if you were going to go in those careers, yeah, most likely they're going to be with a pile of rubble sitting in front of you at some point in time. Yeah. So that I'm giving this awareness and understanding what to take, yeah, which are the paths, because it's going to happen inevitably, simply because it's much cheaper to produce a robot that does that instead of a human. You have to give him a raise, you have to attend to him and so forth. Yeah. And then the machine is just one programmer that needs to update maybe something once in a while.
But then, the guy or the woman who's lost their job, they need to do something else, right? Is that going to be involved with big data as well?
Maybe not that much as big data, is more of a digital skills. And I think one of the things that you hear in companies, it's about digital skills and giving to people digital skills literacy, more navigating not only in the information as in internet, but also other digital skills that would help them to change the work. Because of course the automation doesn't happen. These were extreme examples that I told you, but with others, that's going to be kind of small, minute changes that some of the job is going to be automated. So then it's up to you what you do, what the company does. Either they make smaller work hours, or they upgrade the person, or change the skill so that with this free time it can do something else much better. Yeah. One typical example is an analyst. So if now an analyst is a reporting producer, and if you look at any company, so what do? They don't analyze. They just produce reports. And 70 to 80% of the time is spent on that. And then what you can do, you can transfer that, flip it around, that because of automation, the job is done only 10 to 20%. And then actually he analyzes the rest of the time, actually, which brings benefit to the company, yeah, because he knows the data much, he can read through the data.
And if a company does, say, call you in to analyze or to consult, what sort of level of difference can you make? I mean, maybe there's been an example from the past where you've gone in there and seen things which they weren't aware of, and it's made a radical difference.
Yeah, I think there was one company that I was working on, and one of the things was that simply they had a report that had to do every month. So there were a lot of elements that you had to do. So first of all, there was like a web page where you had to go to that web page, then download these different files, then you had to combine them, clean them, sort them out, then you had to do a lot of mapping. So there were a couple of people involved. I mean, not full-time, but still many people involved in this whole process of delivering this report for you in the end of the day, for the top management. And in the end, what we did is we created automatic downloading. So automatically it goes in the webpage itself. It realizes when is the latest file. It automatically downloads that. Then when it's downloaded, it picks it up from the right folder. It automatically combines them, cleans it out, sets it out. And then in the end, you just have already a clean report ready to be consumed. Yeah. So, and then the amount of manual work was reduced quite significantly simply because of that you know what are the steps and you know how you could automate them, because downloading, going to the web page, putting your credentials, going to this button, these things that you could automate.
So turning to your sort of academic side a little bit, yeah. When a student comes to SSE Riga and takes a couple of your courses, how are they different when they emerge at the end in terms of their approach to data or their approach to presenting things than they were at the beginning?
Well, there are multiple things. First of all, they will have awareness of the modern trends that are happening in the industry. So not in the industry, but in the companies, in terms of digitization, in terms of artificial intelligence, in terms of automation. So they will be able to select the right career paths simply because they will know that, going into accounting, as much as I would love it, I might have to tweak it a bit, because most likely that job is not going to be there in 10 years' time. Mm-hmm. Then they have a completely different approach in terms of how they analyze the data, because you cannot imagine in so many companies that analyzing data is so inefficient. You would do you would have so much data, and then you don't kind of condense that to understandable format. And what I teach them is, how you condense that to understandable format, that you can access any sort of subset of data, any data in just one simple table, how you do that. And from that, you can actually know where to kind of learn, like what would be steps. Plus, they have a kind of a checklist, what they need to do whenever they approach the data. So, for example, there's 5 rules in terms of how to prepare the data, then 10 rules how to set up the report. And, they would have this knowledge how to approach any analytics, no matter what it is, no matter what kind of data that the life throws at them.
Well, I got you to talk about the 5 rules earlier. I'm not going to ask you to do the 10 rules. That would be unfair. But maybe just to wind up, you could give us one thing to bear in mind when approaching any kind of data set, something that will kind of get us off on the right footing.
Yeah, I think the simplest is getting friends with the data. What does it mean? It means that when you look at any data, you try to, before actually I do anything else, I look at, okay, what's the total sum of it? Yeah? What are the minimum, maximum values? Do they make sense? Yeah? What are the different subsets or the different dimensions of the data? So you have a look at what the data tells you, just without any analysis. Just look at the bare things, and then start from there. Maybe the data is wrong, because I've had so many cases where somebody sends me the data and I say, can it be more than 100%? Oh no, sorry, we forgot this filter, or we did something wrong. Yeah, and then all your work would be in waste if you just don't do these basic checks. Yeah, just getting friends with the data. That would be this golden rule.
Brilliant. That's actually given me something that I can understand and I can try and apply next time I'm faced with some figures or some charts or whatever. So, Rihards Garančs, thank you very much for joining us here today.
Thank you for having me.
Thank you for listening. This podcast was produced by SSE Riga. If you'd like to learn more about the topic, visit the open course schedule at SSE Riga Executive Education. For more podcasts, find us on Spotify, iTunes, or the platform of your choice. Remember, share this episode with your friends and colleagues.